In this video, we are going to go over how to find solutions to equations with two variables. And you might be thinking, oh my word, how do we find solutions to equations with not one, but two letters in them? We're gonna rock it. These equations are called linear equations, and they're called linear equations, and I'll write that word out for you right here, linear. They have the word line in them, so linear equations. And the reason why they have the word line in them is when you learn to graph these out, and we will be learning how to graph these out in a not too distant video, you will learn that the graphs look like lines. So you can almost think of the word as liner or linear, right? Making a line. So for now, we are going to write out solutions. So we're just going to, as the instructions say, find three solutions to each. How do we find solutions? Well, we're going to simply pick any x value that we want, and we'll plug in that x value into this side right here, into this equation. That will be our input, and we will get an output of a y value. So our solution will actually be two values, x and y. And if that looks familiar to things that you've done with functions in the past, and you might be thinking, well, that looks an awful lot like a point on a graph, you're not wrong, and we'll see how that relates again in a later video. So for now, I'm just going to pick random x values to find solutions to this equation. So I'll pick x equals 0, I'll pick x equals, I don't know, 6, and x equals 10. And you might be thinking, how did Mr. Gurdon come up with 0, 6, and 10? Well, the answer is I randomly picked them. You could pick 2/3. You could pick -5 or -7. As long as they are any real numbers, any number, decimals, fractions, anything you can think of, you plug them in, you add 7 to them, and you will get out a y value. So there are literally infinite solutions to these equations. It just depends on what x value you plug in and the y value you get out. Very cool. So we plug in 0. So I've made a table to kind of organize our thoughts here. You don't have to use a table, but I like it. It organizes things. We plug in 0 here. So we get y is equal to 0 plus 7. We're plugging in 0 for x. 0 plus 7 is 7. So that's what we get out of that work. So you can almost put an equal sign there. So we get out 7. And that means that the solution is 0, 7. And yes, that is a point on a graph. And again, you will see that in a later video. So 0, 7 is a solution. How do we know it's a solution? Because when we plug x equals 0 in here, we will get also 7 out here. So I'll go back and show you how to check that in a moment too. So now I plug in 6. So I do y equals 6 plus 7. 6 plus 7 is equal to 13. So that is going to be my y value. So my solution is 6 for x, 13 for y. So that means when x is 6, y is 13. A solution to that equation. Last but certainly not least, you've got 10. So I'm going to plug in 10. Again, I picked random numbers here. Plug in 10 for x, and now I add 7. 10 plus 7 is equal to 17. So the point or the solution that I have out is 10, 17. Beautiful. So how do we know that these are solutions? Or let's say that I were to give you 10, 17 and say, this is a solution to that equation. How would you know? You'd plug them in to the corresponding x and y spots. So I'll just show you one example of that. So if I take 10 and I put it in for x, and then I put y, which is 17, in for y, we should get a true statement if these are indeed solutions, right? A solution is a value or values that makes an equation true. So 17 equals 10 plus 7 is 17. And because that equation is true when we evaluate x and y into the equation, we know that 10, 17 is a solution. The same can be done for 6 and 13 and 0 and 7. It's a beautiful thing. All right, so at this point you might be thinking, I am ready to rock on this stuff. Or you might be thinking, I need a little more help. If you need that little more help, I've got a second solution problem for you. If you're good, then we'll leave it there. I hope that you stick with me though. Let's do this. So I got y equals -2x plus 4. We are going to again find three solutions to this linear equation. I'm going to pick three random x values. I'm going to start with a negative value. Let's do -3. And then I'll go to, I don't know, well, I'll pick 0 again. That's always a nice number to plug in. And then I'll pick 5. Again, three random x values that we can plug in. Now I'll do the work here. So I'm going to just do y equals -2 times -3. Plugging in -3 for x is +4. And we do out the work. -2 times -3 is +6, +4 is 10. And so the solution is when we input -3, we get an output of 10. So -3, 10. Oh, it's beautiful. That's one solution. Next, we're going to plug in 0. So I get y equals -2 times 0 +4. Again, just following the function rule, or the linear equation, and now we'll evaluate it out. -2 times 0 is 0, +4 is 4. So I have the point 0, 4. Beautiful. Beautiful. All right, we'll keep going from there. Now, I've got the equation -2x + 4. So I've got y equals -2 times 5, as I was just mentioning. That -2x + 4 is the same equation that you've had the whole time. You might be wondering, why is he stating that one for the third time? I'm just reminding you that that is the rule we're going off of. We've plugged 5 in for x, now we'll simplify. -2 times 5 is -10, + 4 is -6. And so now we have the solution 5, -6. So these are all solutions. Oh, it's beautiful. So now from here, these are 3 solutions that I have. You can check any number of them. I'll just go over one just to basically verify it's a solution. We'll start with -3 and 10. If -3, 10 is a solution, then when I evaluate it in for y and x respectively, we should get a true equation. So 10 is the y value. So I'll put 10 in for the y place. That should be equal to -2 times -3 + 4. -2 times -3 is 6. And 6 + 4 is 10. We get a true statement that 10 is equal to 10, so we know that that is a solution. So what's the point of all this? We've gone over how to find solutions to equations with 2 variables, and it's actually not so bad. It's a little bit less about, I guess, solving and getting a variable alone like we would do in other equations, and more about picking any input values and correctly evaluating them to find the output values, which then make the equation true. Awesome, awesome stuff.